In the previous lesson, we learned what a polynomial is and learned some terminology. Now, let us use that knowledge to do something useful with polynomials. The goals for this lesson are to find the value of a polynomial and also to find the zeros of a polynomial. These are crucial computations in a large number of applications. For example, elliptic curve cryptography uses polynomials to protect messages. You can design planes on computers, and when they do that, they compute the drag on airplanes using cubic polynomials. The petrochemical industry uses simulations, and those simulations involve polynomials. These are just a few examples of a huge number of applications of polynomials. We will now discuss finding the value of a polynomial. A polynomial is an expression involving some variable. For example, here we have a variable x and a polynomial is x squared minus 2x. For different values of x, x squared minus 2x takes different values. For example, if x is 0, the polynomial takes a value 0. If x is 1, the polynomial takes a value negative 1. We will discuss how to find the value of a polynomial. We may want to find the value of a polynomial when the variable has some specific value, for example, x equals 2. Let us look at an example to see how we will do this. We have a polynomial given over here. This p bracket x is called p of x. It says that p is the name of a polynomial and x is the variable in the polynomial. If you want to find p of 1, that is the value of p of x when x has the value 1. So the way you calculate it is you will say p of 1, I will replace all the x's in the polynomial with the value 1. For example, I have 5 times 1 cube minus 2 times 1 square plus 3 times 1 minus 2. We can calculate this, and this has a value 4. So what we did is, when we wanted to calculate p of 1, we replaced x by 1 in this polynomial. So what is p of 0? You will replace x with the value 0, so you get 5 times 0 cube minus 2 times 0 square plus 3 times 0 minus 2, which is just minus 2 or negative 2. That is how you calculate p of 0. Let us now do some examples with the polynomial p having the expression 5y squared minus 3y plus 7. Calling it p of y tells you that y is the variable. What is p of 1? You can try it yourself. You can replace the value of y by 1 and evaluate the expression. When you replace y by 1, you get 5 times 1 square minus 3 times 1 plus 7, which is 5 minus 3 plus 7, which is 9. Now, can you evaluate p of 2? You will replace y by the value 2. You will get 5 times 2 square minus 3 times 2 plus 7. 2 square is 4, so 5 times 4 gives you 20, minus 3 times 2 is 6, and then you have plus 7, so it gives you 21. I hope you got this right. You may also be given the question as, what is the value of p of y at y equals negative 2? It's the same as saying, what is p of negative 2? So can you do it? you replace y with negative 2. So here you have 5 times the square of negative 2. Okay, 5 is not squared, only the negative 2 is squared, so that becomes 4. So it is like 5 times 4, which is 20. Then minus 3 times negative 2 or minus 2, so minus and minus become plus, so it is a plus 6. And then you have a plus 7, so if you add all of these together, you get 33. Now, you may be asked the question, what is P of A? And you might wonder, how will I find the value of P of A when I don't know A? And you cannot find a numeric value, but here A is some constant. What it says is that A is some unknown constant. So you try to replace y by A and find out what the expression is. You will get the expression 5a square minus 3a plus 7. Okay? But this is not a polynomial, this is an expression for some constant value of a. Okay? A is a constant, but we don't know what it is. So it has only one value, we just don't know what that value is. So we cannot find a numeric value for a, but you shouldn't think of 5a square minus 3a plus 7 as a polynomial. It is some value, we don't know what it is. We will now discuss the zeros of a polynomial. This is one of the most important applications of polynomials. We are looking at the same curve that we had looked at earlier. You notice that at some points, for certain values of x, the polynomial takes the value of 0. The values of x for which the polynomial takes a value of 0 are called the zeros of the polynomial. For example, this polynomial takes a value 0 when x is 0 and when x is 2. So 0 and 2 are called the zeros of this polynomial. In general, if p of c is 0, then c is called a zero of the polynomial. It is obtained by setting p of x equals 0 and finding out for what value of x is p of x 0. So the value of x at which p of x equals 0 is called the root of the equation p of x equals 0, and that also gives you the 0 of the polynomial. So they are almost interchangeable. Let us look at an example. We have pxx equals x squared minus 2x. We saw earlier in a graph that it becomes 0 when x is 0 or when x is 2. The way you actually find it out is you replace x by the value that you think is a 0 of the polynomial and verify if it is actually 0. So when we want to find p of 2, we say 2 squared minus 2 times 2, is it equal to 0? Yes, it is equal to 0. So 2 is a 0 of the polynomial p. Okay. We also looked at the graph earlier and said that at x equals 0, the polynomial looked like it was 0. Okay, so can you evaluate it? Can you check if p of 0 is indeed 0? To find p of 0, you will replace x by 0 in this expression x squared minus 2x. So you have 0 squared minus 2 times 0, which is 0. So is 0 of p? Yes, it is, because p of 0 is 0, so 0 is a 0 of p. In general, 0 may not be a 0 of p. Okay? So in this particular polynomial, it happens to be a 0 of p, but it is not always true. When you are operating with polynomials, it is common to make one particular mistake, so I will tell you how to avoid it. It is safe to use parentheses to avoid this common mistake. Okay? So let us say I am looking at p of x as x squared minus 2x. What is p of negative 2? You will replace x by negative 2, right? If I put parentheses around negative 2, I know it is the square of negative 2 minus 2 times negative 2. I can evaluate it as 4 plus 4, which is 8. So this is correct. Okay? If you don't put the parentheses, then you may write the expression as minus 2 squared minus 2 times minus 2. Minus 2 squared is evaluated as doing 2 squared first and then adding a negative sign to it, the minus sign. So then you evaluate 2 squared as 4 and then add a minus sign and say it is minus 4, and then you add floor to it and get 0. this answer is wrong. Okay? And you made this mistake because you did not put parentheses around the negative 2. Okay? So it is always safe to put a parenthesis around negative 2 so you don't make this type of mistake. You can also make a mistake like if I want to calculate p of a plus 1. This is a more advanced calculation, but if I wanted to do that, I need to replace x by a plus 1. Right? So I have a plus 1 square minus 2 times a plus 1. You can evaluate a plus 1 square as a square plus 2a plus 1. So you get the first 3 terms on the right hand side, and then minus 2 times a plus 1 is minus 2a minus 2. You can take the common terms. The a square goes outside. You have 1a square. The 2a and the minus 2a cancel out each other, and 1 minus 2 becomes minus 1. So you have a square minus 1. This is correct. But if you did not put a parenthesis, then you would actually replace x by a plus 1 and you will say a plus 1 square. So you are squaring only the 1, not the a. Okay? Then you will write it as minus 2 times a plus 1. That is, you are multiplying only a by 2, not the 1 by the 2. Okay? And if you simplify it, you will get an expression minus a plus 2, which is not correct. Okay? So what you should always do is when you are replacing x by some number, put parentheses around that. We have learned how to check if some number is a 0 of a polynomial by finding a value of the polynomial for that value of the variable, but we have not found how to actually come up with that number. Okay? In general, it is a difficult problem. What we'll do is we'll look at the 0 of a linear polynomial. For a linear polynomial, finding the 0 is easy. Okay? So let us say p of x is ax plus b. A cannot be 0, otherwise it's a constant, it's not a linear polynomial. So in that case, to find out the 0 of the polynomial, we want to solve p of x equals 0. The solution to this is called the root of the polynomial equation p of x equals 0. Okay? So how do you find it? You want ax plus b to be 0. This symbol next to it says it's equivalent. Okay? So that is, the left hand side implies the right hand side and the right hand side implies the left hand side. Okay? So ax plus b equals 0. So ax is negative b. So x is minus b by a. So a linear polynomial has one 0 and the value of the 0 is given by negative b by a. Let us look at the example 2x minus 1. It is linear because the power on x is at most 1. It has the form ax plus b with a equal to 2, that is the coefficient of x is 2, and b equals negative 1. That is, the constant term is minus 1 or negative 1. So what is minus b by a? You replace b by minus 1 and a by 2, so you get minus of minus 1 by 2. The minus and the minus become plus, so you have 1 by 2. Okay, that is half. It's good to also verify if your answer is correct. You have got the answer, it's good to check if it's correct. How will you verify if half is actually a 0? You will check if p of half is 0. Okay, so you replace x by half and then you get 2 times half minus 1, which is 1 minus 1, which is 0. So we have verified that half is a 0 of p of x. Let us summarize what we learned today. Given the value of a variable, we learned how to find the value of a polynomial. We also learned how to verify if the value of a variable is a 0 of a polynomial. That is, if I gave you the value of a 0 of a polynomial, you can check if I'm actually correct. We learned how to find the 0 of a linear polynomial. That is, we want to find the root of a linear equation.